Nous allons passer à la session géodynamique et ressources naturelles, avec une première communication longue du professeur Jörn Thiede, qui nous vient de l'Académie des sciences de Mayence et du GEOMAR de Kiel. Et j'appelle aussi les deux présidents de la session, Francis Albared et Jérôme Gaillardet, qui vont venir présider cette session. Je remercie Jörn Thiede.
Pour les organisateurs.
Merci. Il va parler en français.
Non. Merci pour l'invitation. Malheureusement, mon français est très mauvais et c'est nécessaire pour moi de parler en anglais. And so, as you can see from the slide, I'm also working in St. Petersburg, and in these days, it's for Westerners more easily to get around in St. Petersburg speaking English. Now, somebody changed my title, and so I thought I address also a little bit how French, in my vision, appear in the Central Arctic. And so I will make a statement that French research is present in the Arctic, in the Central Arctic. I'll make one sentence to Avipef, one sentence to Damocles, and one sentence to Victor 6000. But the marine geosciences are largely absent. And so I think this would be a very interesting contribution if French marine institutions would devote their attention to the Arctic. But this naturally needs a focused science program and access to the needed infrastructure. Now, the Arctic research really started when the first dedicated polar research vessel was built by Fridtjof Nansen as a young man. He had the vision to go to the North Pole because, as Bert Rudels told us, the remains of the Jeannette expedition had been found of southern Greenland, and Nansen wanted to pick up on this idea to drift across the Arctic Ocean, reaching the North Pole. Now, we naturally know in these days, and this is the map of his drift route, he brought his ship into the sea area to the north of the New Siberian Islands, and he bypassed the North Pole. He tried to walk there, and if you look very closely to the map, you can see that he left. He left the farm here about this area, and then he had to go back on skis and overwinter in Franz Josef Land, and he was almost killed by this attempt. Anyway, this idea was picked up again during the last IPY, and the French decided to go with the sailboat into the Arctic Ocean, the Tara, and they drifted across the Arctic Ocean, and the same way as Nansen missed the North Pole, they also missed the North Pole. And so, but they confirmed some very interesting observation. Nansen took about 3 years to drift from the New Siberian Islands with Fram into the Fram Strait. Tara only took, I think, less than 1.5 years. And so they could document that the circulation or the circulation system of the Arctic sea ice has sped up considerably. And so I think this is a very important point to make. Now, the second example, I think we have heard about this on the first day by Yves Renaud and Roland Neuber, is the French-German station in the Holocène. They make very sophisticated atmospheric measurements and observations on the aerosols, and they have actually recently been awarded an international prize for the quality of their measurements. And I think it's a good idea, if you have modest means, to put these means into one basket and then try to combine the strengths of both groups. This experience is also full of surprises, because you have to decide if you have a German or a French station leader. You have to make a joint budget and so on. So I can promise you this is really full of surprises, such an experiment. The third example I wanted to show you is that we installed Victor 6000 of Ifremer on Polarstern, because in the Central Arctic Ocean, only few of these sophisticated instruments and robots have been really deployed, and you need a powerful icebreaker to go into the ice. And then you need protection. I will come in at the end of my talk back to this question. You need protection and a safe working condition. And so Victor 6000, I'll give you one example of the fantastic results they obtained. There's a mud volcano in the northern Barents Sea, the Håkon Mosby mud volcano. and there are lots of fixed installed observatories now on this mud volcano. But this was actually poorly known, and this is a bathymetric map of this mud volcano from the time before Victor was deployed. And then Victor made a very detailed set of photographs and of depth measurements of this mud volcano, and now you can really take samples in a very oriented, very precise way. And I think it's the way forward to bring these sophisticated robots into the Arctic Ocean. Now we are naturally Fridtjof Nansen's farm and the Norwegian Maud and the German Gauss represent the first generation of dedicated polar research vessels. They all could go into the ice, provided safe working conditions, and they were the most modern instruments at that time, more than 100 years ago. Nowadays, we have a new set. It took almost 80 years to generate this new set of dedicated polar research vessels, which are powerful enough, at least during the summertime, to go to the North Pole. We have in Germany Polarstern, the Swedes have Odin, the Americans have Healy, and the Koreans have Araon. And I think we'll see how important the involvement of these ships is into Arctic Ocean, by the way, also into Antarctic research, naturally, because they are really have the ability, at least during the summertime, to reach the North Pole at liberty and to, almost in all parts of the Arctic Ocean to sail. Now let me talk on the scientific substance of my talk. I would like to address three scientific topics and then a consequence I would like to draw out of these discussions. I have to address the structure, nature, and age of the Arctic Ocean basement. And you will see that there's really big gaps in our knowledge. We have to talk about the long-term history of the Arctic environments, and the most important data set comes from one drill site, actually. Then I will address the Arctic Ocean during the latest past, and finally I will hopefully demonstrate that isolated national efforts, which will continue, but they should be well coordinated and combined in international programs. Now, the Arctic Ocean itself, you need, we are all coming from non-Arctic countries, and you need a motive to go into the Arctic Ocean. And this motive is really given, as addressed by Bert Rudels and other people in this, by the circulation system you have in the North Atlantic Ocean. You have the Gulf Stream system coming across the North Atlantic Ocean, and then split up into one arm going to the south and one arm going to the north, and this is forced by the physiography of the continental margins. And the Gulf Stream is continuing along the Norwegian continental margin into the Arctic, and then splitting up into an eastward bending arm and a northward bending arm bypassing Svalbard. And so this is a system under stress. It's changing fast. It's monitored in detail. There are some important fronts in the Norwegian Greenland Sea, and I think this oceanographic gradient is a very important to be observed and to monitor, and I think we can contribute, at least on the long-term history from geosciences, substantial knowledge to this problem. Now, you will understand that you're not really able to understand this system if you don't include the Arctic Ocean to these observations. And I think the freshwater input, which comes from Siberia and which you can trace in the surface waters across almost the entire Arctic Ocean, basically to Farm Strait, this is a very, very important element because it stabilizes the sea ice cover in the Arctic Ocean. But this slide should also give you a motive for the involvement of the Northwest European countries, including Russia, because politically it's quite clear, stated by Jens Stoltenberg from Norway, by Angela Merkel from Germany, by President Putin in Russia, that the environmental change going on in the Arctic Ocean on the Northern Hemisphere is very fast, but it's the most important societal problem we are all facing. And so I think we are in a very good position to argue for, if they come up with such an argument, that they also should invest into Arctic research. Now, the bathymetry of the Arctic Ocean is naturally nowadays much better known than previously. On the right-hand side, I'm displaying the map which Fridtjof Nansen published after his famous expedition 1893 to 1896, and he had, from his previous knowledge from the Norwegian Greenland Sea, the understanding that he was not only drifting along a small channel here outside the continental margin, and he had observed the continental margin only to the north of the New Siberian Islands. But this was really a contiguous deep sea basin covering almost the entire Arctic Ocean, connected to the Norwegian Greenland Sea through Farm Strait, and he thought at that time that this was a relatively shallow channel. Nowadays we have a detailed and almost annually updated knowledge on the bathymetry of the Arctic Ocean. We know there's a deep Farm Strait, there's a deep eastern Arctic Ocean basin, and then there's the Makarov Basin to the west of the Lomonosov Ridge, and then you have the Alpha Menelaev Ridge complex. You have the Canada Basin, and you have a number of marginal plateaus like the Maurice Bryce, the Yermak Plateau, and the Northwind Ridge complex. The details of this bathymetry are still not really well known if you go. So Healy and Polarstern in 2003, during the Amur expedition, made a very detailed investigation of the southern part of Gackel Ridge to the north of Farm Strait. And Polarstern data are covering the southern flank of the ridge valley, and Healy data are covering the northern ridge, and we found out that the entire ridge valley is quite deep. It's a very slow opening segment of the mid-ocean ridge system, and it's very anomalous, and one had actually anticipated on these slow opening rates, which were known from the magnetic anomalies. You will see this in a minute, that there was little magmatism and little volcanism. We found out that there's really lots of volcanism to be observed here in the Rift Valley itself. But then numerous dredging stations also showed that beside basalts, which are the red dots, there are also rock types like peridotites and gabbros, which are occurring quite frequently in the Rift Valley. And you have to think about a tectonic process in placing these materials, because these rocks are formed in several tens of kilometers of depth below the ocean, below the seafloor. And so there are many exciting problems waiting. We also found many signs of hydrothermal activity, and I think it would be a challenge to bring an instrument like Victor or one of the deep diving submarines into this Rift Valley and to try to find the hydrothermal vent faunas, which are known from the northernmost part of the Norwegian Greenland Sea or the entrance to the Barents Sea. And we have one fossil example here from the intersection of the Gackel Ridge with the Laptev Sea margin. Now the northernmost or the northernmost part or the easternmost part of Gackel Ridge is virtually unexplored, and in particular we have no real idea how this intersects with the Laptev Sea continental margin, and how this plate margin then continues into the continent. You have some idea from the distribution of earthquakes, but this is still quite vague. Now let me go on. We have a quite good understanding of the young plate tectonic movements in the North Atlantic Ocean with the mid-ocean ridge, which can be traced through the North Atlantic, through the Norwegian Greenland Sea, into the eastern part of the Arctic Ocean, the Gackel Ridge, through Farm Strait. And we know that the eastern part of the Arctic Ocean, the eastern basin, opened almost at the same time as the Norwegian Greenland Sea, starting about 54 or 55 million years ago. There was another arm of the mid-ocean ridge which during Paleogene times opened up the Labrador Sea and separated Greenland from northern Canada. And so this part of the story is quite well understood. The reddish and yellow hues are reflecting Cenozoic ages, and the green and blue hues are reflecting Jurassic and Cretaceous ages. And so you can see that this is a young basin of the Arctic Ocean. But then if you come to a Lomonosov Ridge and try to find something out about the age of the oceanic basement to the south of the Lomonosov Ridge, I think you will find out that there's very, very little known on the age of the magnetic anomalies are almost indecipherable. There are few basaltic samples which have been dredged and now also caught by our Russian colleagues during 2012. They all indicate that the features you can sample are of Cretaceous age. But this is the largest contiguous piece of ocean crust on Earth, which is not understood in terms of plate tectonics, and we need this urgently because they're waiting a number of problems to be resolved. Now, one is our Russian colleagues are interpreting the crust of the continental margins and of the deep ocean adjacent to their continental margins to define their claim for the extension of the exclusive economic zone into the Arctic Ocean. And so this is from a recent paper, 2013, of Laverov, the vice president of the Russian, or the former vice president of the Russian Academy of Sciences, and some colleagues from the Shirshov Institute, who have an idea how this Makarov Basin complex opened and developed, and how the Alpha Mendeleev Ridge complex are connected to that, including the Northwind Ridge complex. But this is not really based on any solid data. This is an idea, a type of a model, and so I think this leaves a lot of debate. And so in the same paper, they published then, based on their geological arguments, the extent of the Russian claim for the central part of the Arctic Ocean. And when you know that the Russian Resource Ministry is quite touchy as soon as you try to sample data, to collect data below the seafloor, you will see that a major science policy problem is ahead of us, because I think they have enough data in hand that this claim will be granted sooner or later. But then I think this tells us we should very closely collaborate with our Russian colleagues to make sure that we still get access to this area, and that we can contribute to resolve these geological problems. So now they have a deep diving submarine which belongs to the Russian Navy, and they have sampled last year the Mendeleev Ridge, and there's lots of very, very interesting data coming out of these Russian expeditions. Now, if you look at the initially, you need a detailed, high-quality, multi-channel seismic reflection network of profiles. And when you look at this part of the Arctic Ocean, you will see that this is really a big deficit. There's not many lines here in the Eastern Arctic Basin and in the Makarov Basin and the Alpha Mendeleev Ridge area. The Canada Basin seems to be much better covered, and so I think we need icebreaker time during the optimal season of the year to make this network of profiles denser. This has been compiled by Yngve Kristoffersen from Bergen in Norway for one of the workshops which have been conducted to prepare for Arctic deep sea drilling. But I think there's a real need, urgent need to get more ship time for this type of investigations. And this can still be done with ships like Odin and Polarstern and Thiele, and so I think this should get quite a bit of priority. Now let me switch then over to the Arctic Ocean paleoenvironment. We had a hinge that for many years, since the Fletcher Ice Island, the American Fletcher Ice Island, had taken 3 short cores covering obviously older sediments than just the glacial quaternary sediment cover, until the Canadians, I think in the 60s, carried out their Caesar experiments and succeeded to collect this very strange sediment core, which consisted of glacial sediments on top, but then laminated sediments in the lower part of the core, and these sediments were geochemically very strange because there were lots of barite crystals in the sediment. But besides that, the sedimentologists then and micropaleontologists investigated the contents of these sediments, of these lamina, and they found out they were of pristinely preserved silicious microfossils, which seemed to indicate that the Arctic Ocean was ice-free and covered by temperate surface water, at least during the times when these organisms lived. And micropaleontologists have recently gone back to this type of cores and found out that and they believe this is reflected in annual layering. And during the winter layers, they found a thin sand layer, indicating that there was sea ice, even during these climatic phases when the Arctic Ocean was apparently relatively warm. And so the Arctic Ocean was obviously, even during the warm climatic phases, on a brink, on a threshold, and froze over, at least in part of the area during the winter time. So I thought this was a really exciting experiment. And so then the real breakthrough was brought about, at least for the long time scales, by a courageous ECOD expedition, the European Consortium of Ocean Research Drilling, which organized an expedition, very expensive but very successful expedition of 3 ships. On top you see the Russian nuclear icebreaker Soviet Soyuz, then Odin follows, and finally the drilling barge Vardar Viking, Odin and Polash and Sovietsky Soros were supposed to keep the drilling platform operable because the drilling platform did not have the possibility to a dynamic position. But the expedition, 3 weeks long in 2004, was a great success, and lots of highly exciting data came out of it. And so maybe my illustrations are not quite up to date, but I think the basic message is still there. Now they visited an area on the top of Lomonosov Ridge, very close to the North Pole, which had been traversed by Polarstern and Odin in 1991 during the first trip and first visit of conventional icebreakers to the North Pole, which is now routine and nothing special. But at that time it was very special, and we were very surprised to find such a undisturbed sediment layer on top of Lomonosov Ridge. And this was then the target of this expedition, and they found out that there is a very complicated but very interesting sediment sequence, which they recovered in the uppermost part, consisting of deposit under glacial conditions. Then you get into of an age distribution, which I will show you in a minute. Then you get a very, very important and interesting freshwater event, and you get into sediments which reflect the Paleocene-Eocene thermal event. Now, I have no time really to go into any details, but I want to show you one record which really should bring us to think about the age of the Northern Hemisphere glaciation. There's an age scale from 0 to 50 million years ago. You see that the onset of the ice rafted material in these sediments is very early, much earlier than in Antarctica and much earlier than one believed hitherto for the Arctic. And so there's a modest beginning. This stratigraphic segment is spread out here, and you can see that it starts relatively slow, but then it reaches very, very quickly values which correspond to the younger part of the record, including the occurrence of large ice raft of ice rafted pebbles and grains, which are usually interpreted as reflecting sedimentation from icebergs. And I think this is a fantastic, interesting record, even though it's interrupted by long gaps in these stratigraphic completeness, long hiatuses, and we still have to think about how these hiatuses originated. But it's quite clear that the Northern Hemisphere glaciation goes much further back in time than we believed hitherto. We knew this from drilling in the Norwegian Greenland Sea and in this northernmost Labrador Sea, which had documented Miocene and Pliocene ice rafting, but now we have to think about and reflect about where this ice could have been. Now, my idea is that there's really that the Arctic Ocean always was on the brink of being cold, at least during the winter time. And so then during the about 50 to 48 million years ago, we had a major plate tectonic event because India had been transported by plate tectonic movements across the Indian Ocean. It was impacting on the southern continental margin of the Eurasian platform of the Eurasian continent. And so this entire movement, or this collision, then tipped the platform to the north, and with the result that all the rivers in northeastern Europe and in Siberia are flowing into the Arctic Ocean. This has nationally important consequences. I'll not go into any detail, but I will use a map published by Admiral Gorshkov, which displays these large salinity anomalies along the Eurasian shelf seas, which are extending far out into the Arctic Ocean, and which are fed by mainly by the Siberian rivers, and which must have an important influence on the sea ice cover, and many people call actually this area the sea ice factory of the Arctic Ocean. Now, our dream is to complete this geological record by establishing a comprehensive drilling program, and there have been workshops in the recent past, and they have identified a number of priority areas. If you want to go to look at the late Mesozoic and early Cenozoic record, you want to go to Alpha Mendeleev Ridge, obviously. Then you want to go back to Lomonosov Ridge and try to establish a transect along the axis of Lomonosov Ridge, and you want to go back to the continental margin and see if you can find high resolution sediment records to give you more detailed about the distribution of the ice sheets on the continents surrounding the Arctic Ocean. Now we have collected sediment cores from the central part of the Arctic Ocean for many years, as long as these icebreakers have learned to enter the central part of the Arctic Ocean. But most of these cores are only so 5, 6, 7 meters long, and I think it would be a grand French contribution if the Calypso system could be deployed on one of these icebreakers. It's technically not very easy because this icebreaker or the Calypso system has some technical requirements. But I think it would be a fantastic contribution if this could be achieved. Now, if you look at one of these cores to the northeast of Greenland, this is one of the Polarstern cores, which is collected from the Condel margin of East Greenland. You get quite long stratigraphies, 500,000 years or so, and you have the oxygen isotope record and our interpretation of the marine oxygen isotope stages. And you can see that there's an almost uninterrupted record of, maybe with one exception about 400,000 years ago, of ice rafting. And so I think the Greenland ice sheet is a long and stable feature, and I think based on the deep sea records of ice rafting, it's even much older and much more stable in the tertiary than we can document by means of these cores. But there are long timescales involved in the history of this glacial cover. Now, the extent of these ice sheets, at least in northwestern Eurasia, was for a long time not really well understood, because nobody had really put enough projects together to document them. And then in the early part of this century, we put a lot of Russian Western bilateral projects together and tried to start out the extent of these ice covers. Now this displays the last glacial maximum ice cover. There was an area of certain uncertainty. This ice cover sheds icebergs into the area, and you can document actually the seaward end of the ice sheet by finding sediment cores with undisturbed and complete stratigraphies through the last glacial maximum. You could show that there was an area of uncertainty. You could also show that if you go back into stage 4, there was a much larger ice sheet which was heavier to the eastern side. And then if you look in detail on the map, we find moraines here indicated by these green lines, which are much older and documented much larger ice sheets, where we are not so sure how old this could be. But this is then reflected in the central eastern Arctic Ocean ice record. I will display here on the left-hand side, arranged according to longitude, the ice sheets, and you see the position of the rivers Ob, Yenisei, and Lena. Here the marine isotope stages, and here's an age scale back to the last 200,000 years. You can show that the ice sheets were not present there permanently, but they were interrupted, and we know from drilling in the Norwegian Greenland Sea, there were actually 28 or 29 large glaciation events which affected northwestern Eurasia, and which left their traces of ice rafted material in the ocean. Now, in the times when the ice sheets were shrinking or were small, planktonic foraminifera are present in the central part of the eastern Arctic Ocean, documented that you are largely dealing with the sea ice cover and not with an ice shelf. But I'll come back to that. So there's one. This record can be documented by means of the occurrence of ice rafted material. You can see that during stage 4 and stage 6 here, there are large anomalies of ice rafted material. There's this exception of the situation during the stage 6, and I'll come back to that on the next slide. Then there's an important input of freshwater. Each time the ice sheets are falling apart, and we think that there's a highly variable history preserved in these Central Eastern Arctic records. It's surprising to note that the last glacial maximum in the eastern part of the Arctic Ocean does not find its reflection in the input of ice rafting material. So then the ice sheet was more active further to the west. Now, there's this exception during stage 6. There was strange observations from the Lomonosov Ridge where they found these glacial features in almost a kilometer of water depth, which seemed to indicate erosion by a deep reaching ice. They have mapped this out, and there's erosion on the European side of the Lomonosov Ridge, and you find the sediments dumped onto the Eurasian side, and so people think that at least under exceptional conditions there may have been large ice sheets extended from Europe into the eastern part of the Arctic Ocean, but also coming from the North American continent. So I think this is a very interesting observation, which has been is based on many data collected by Odin and other ships, and so I think we have to think about how such an ice sheet could extend so far into the Arctic Ocean. Now let me get to the last two examples very quickly. You know that there are huge permafrost areas in northern Russia, and they have developed these large ice complexes on the shore of the Laptev Sea. They are deteriorating quickly in the moment. They're freeing these fantastic fine fossils. And André Chaire has recently mapped out the occurrence of these fossils, which lived on the glacial steppes in eastern Siberia. And we know now that they existed at least for the last 60,000 years, and the last mammoths died out about 4,000 years on Wrangel Island. Now the question was then if the permafrost region extends under the shelf to the north of these ice complexes. And there was always, if you look at the high-resolution seismic pool, there was a phenomenon blanketing out these signals from below. And so there was speculation if this was gas in the sediments or if this was permafrost. And so we sent a Russian drill ship a few years ago into the Laptev Sea and could document that there was really ice in the sediment cores. These sediments are about 16,000 years old, and so we think this is reflecting the occurrence of the permafrost reaching far out into the Arctic shelf seas, at least. My last example is connected to an ice core, to a very young time scale, to a sediment core from the eastern part of the Fram Strait, and to very young time scales. We have been hunting for a long time for high sedimentation rate cores, and this Robert Spielhagen from Kiel has successfully done so. If you look at these sediments, you can map out the polar foraminifera, the left-coiling Neoglobochordina pachyderma, and then you can chart out subpolar foraminifera. You can measure oxygen isotopes and all kinds of geochemical measurements and establish a temperature curve for the last 2,000 years. And the surprising result was that there was a rather stable situation until the earliest part of the latest part of the 19th century, and then suddenly these the frequencies of the subpolar planktonic foraminifera are increasing dramatically, and you can try to estimate the temperatures behind this phenomenon, both based on something like the calcium-magnesium ratios, as well as on ecological equations like CIMAX of these planktonic and you can document that there was a rise of several degrees centigrades in the inflow of the Atlantic waters. And so I think this is a very interesting results coming from these marine geosciences. Now let me come to the end. I think I don't have time really to talk in detail. Well, the European Polar Board has pondered about what should be done in Arctic Ocean research, and they came very quickly to a conclusion that a large icebreaker, internationally run icebreaker, was needed, and I've given a copy of this research perspective for the ERICON project to Edouard Bard, that some of the thoughts may be discussed here in France. We think that the present icebreakers are really reflecting outdated technology. We need ships which can operate throughout the entire year in the Arctic Ocean. They should provide moon pools to deploy sensitive instrument protected against the ice. They should be able to drill And so there's many technical features which are highly exciting, which may mean for polar research a major step forward in entry into a third generation of polar researchers. Now this gigantic ship appeared to be a little bit expensive. It was proposed by ship architects from Hamburg, now belonging to the Wärtsilä company. And we went back last year to Arctic in Helsinki, and they looked at the scientific requirements and came up with a smaller version of such a drill vessel, which is about 1/3 cheaper. And I think this has then much better chances to be realized. Now, if a European or international ship of this type would exist, I think it could provide some focus to many European projects which are today rather isolated, but which could really gain from the synergy of such a ship. And this brings me then to my conclusions. I think, and this addresses also the French community. We are able to draw on the successes of the last International Polar Year, 2007 to 2009, the biggest and most ambitious internationally coordinated effort in polar research to investigate the impact of the dynamics of the polar region changes on the global environment. And I think the French input is very important. We'll be able to draw on novel infrastructure, hopefully run by international consortia and by closely coordinated national polar research programs. The time of isolated national programs, and they will certainly continue both on an individual, on an institutional, or on a coordinated level, they will continue. But I think we should have large, internationally well-coordinated programs. The Arctic is changing fast. We who depend on the properties of the Arctic Ocean and climate should be present there all the time to evaluate the potential and the speed of change in real time. And my last point is, I think exciting times are coming for the next generation of polar scientists, and we will have to prepare for them. Thank you very much.